The Cleaver Bank High Pipeline Project. The project presently consists of a gas export pipeline and a chemical injection pipeline on the bottom of the North Sea. With its overall length of 82 kilometers, it connects the Carrick QA gas production platform to the Clipper PR gas production platform. These platforms are located in Block 49 of the UK sector of the southern North Sea, some 120 kilometers northeast of Bacton and 15 kilometers west of the UK Netherlands sector. As you might imagine, many specialists in different fields were required to realize this project, both onshore in the office and offshore on the vessels. Let's begin with the pipes. The chemical injection pipeline is 4 inches in diameter and piggybacked to the 20-inch gas export pipeline, both designed by Shell. As the pipes needed to be buried in the seabed, a self-burial system was utilized, which consisted of a spoiler profile with a fin. This whole package was strapped together after the anodes were attached to the gas export pipeline pipe to prevent corrosion. The depth from the seabed to the surface varies between 16 and 46 meters, but created no potential problems for the pipelines. Since the pipeline would cross 7 existing pipelines and cables, mattresses were to be installed prior to pipe lay to protect the existing pipelines and cables. Shell Lowestoft awarded the work to Allseas. This meant that Allseas was responsible for all the management, the engineering related to mattress and pipe lay installation, the procurement of all project-related items such as strapping material, spoiler material, heat shrink sleeves, head materials, welding materials, flanges, mattresses and anodes, the management of the 4 and 20-inch pipe fabrication, the fabrication of heads, pipe lay and mattress installation. Altogether, coordinating operations in 4 European countries. The 82-kilometer, 20-inch and 4-inch pipe manufacturing and coating was subcontracted to Chorus in the UK. To manufacture and deliver the required 20-inch and 4-inch pipes, Chorus ordered the 28.6mm plate material from Wust Alpine in Austria. The 4-inch pipe was manufactured by Vallourec and Mannesmann in Germany. Coating the diameter of both pipes was done by BSR in the UK, from where the first pipes were transported to Rotterdam to be loaded on board Allseas pipe-laying vessel, the Lorelei, during mobilization. The rest of the pipes were transported from Hartlepool by road onto pipe carriers bound for the Lorelei in the field. The 20-inch pipe is made from individually manufactured plates. The starting material for the plates is a thick cast plate called the slab. All slabs are marked with a unique identification to make it possible to trace the final pipes back to the slab. Slabs are placed into a reheating furnace in a predefined sequence. When the plate is at the required rolling temperature, the slab is kicked out of the furnace to the rolling mill. After positioning, the slab is rolled between 2 rolls, making the slab thinner, wider and longer. The rolling is performed in several steps by reversing the slab through the rolls and turning the plates 90 degrees to roll it in 2 directions. This is done to create material properties that will be as uniform as possible in both directions of the plate. The final step in the plate rolling operation is thermomechanical rolling, where the plate is rolled at a relatively low temperature, followed by intense water cooling. The irregular plate ends will be cut off by shearing. The scrap will be recycled into new steel for new slabs. After all inspections and tests, the plates are dispatched and transported over the Rhine and North Sea to the pipe mill in Hartlepool. Chorus's Hartlepool 42-inch pipe mill is equipped to produce seam-welded pipes of 18 to 42 inches in diameter, up to 2 inches thick and up to X80 in grades. Here the 20-inch pipe is fabricated. Upon arrival at the 42-inch mill, plate details from Wust Alpine are entered into the tandem computer tracking system. Plates are transferred in batches from the stock bay to the production line, where they are individually fed into the tab welding stations. A consecutive pipe number is marked on the plate and also hard stamped at the tab weld station. The identity of the plate is entered into the tandem tracking system and the next consecutive pipe number is allocated. Tabs are welded to the corners of the lead and trail end of the plate in order to strike up and ensure a complete submerged arc weld along the whole length of the pipe after forming. Each plate is centralized in the planer and clamped. Both longitudinal edges are planed simultaneously to produce a parallel sided plate of accurate width. This operation produces a high-quality finish with the correct edge profile for welding. Edge forming is carried out on the crimp press to a predetermined profile. This ensures the longitudinal planed edges will already have the required pipe contour. The U-press uses curved dies to produce the U-shaped scalp. Positional accuracy is essential to avoid spiraling at the seam in the final O-pressing. O-pressing completes the forming operation by compressing the scalp between the upper and lower curved dies. Formed plates are washed to remove oil and grease and inspected afterwards. Each internal welder has a maximum 4-wire feed, which allows single-pass welding over the full length of the pipe. Each pipe then proceeds to an inspection station, where a visual check is made to identify any welding faults that may have developed on a particular machine at an early stage. At all stages, inspection results are entered into the tandem computer's tracking terminal. The pipes are then forwarded to the external weld stations. Each external welder has a maximum 5-wire feed, which allows for completion of external seam welding in one pass. The pipe then proceeds to an inspection station, where each weld is visually inspected to identify any welding faults that may have occurred. The seam is also ultrasonically tested to highlight any potential welding problems. In addition, daily weld macro samples are removed from pipe ends for interpenetration tests to confirm weld integrity. Pipes are mechanically expanded to create a constant round shape, the last step in the UOE process. Then pipes are transported to the inlet table of the hydrostatic tester. The pipe is positioned in the tester prior to pressure being built up within the pipe. The weld is ultrasonically inspected using a special 28-probe automatic tester, and a full event record is produced during the pipe test. From here, pipes undergo final inspection, finishing and verification checks. These involve measuring internal and external circumferences, ovality, diameter and wall thickness. The unique number of the pipe is hard stamped onto the end bevel if required. Thickness is gauged, finish length determined and typed into the pipe tracking console to add to the quality control records that are maintained in the tracking computer's memory. The computer carries out a further final check when all inspections have been satisfactorily completed. For offshore duty, a pipe will be weighted as well. Completion of the production ends in the stockyard. The pipes are held here briefly until all procedures leading to final certification are completed. These cleared pipes are then loaded to waiting transport to be taken to the coating yard. The 4-inch pipes are made using a continuous mandrel rolling process. The starting materials, called the billets, are delivered to the pipe mill. Billets of specific size and weight are brought into the mill and loaded into the rotary heating furnace. Time and temperature in this furnace is closely controlled. All billets have to remain in the furnace for a fixed period of time, to be heated to the required hot working temperature, which is approximately 1280 degrees Celsius. The hot billet is transported to the cross-rolling piercing mill, where a hollow shell is made. The billet now becomes a hollow of approximately 2 to 4 times its original length. Without reheating, the next step is to insert a long mandrel into this hollow shell. The pipe is then rolled over the solid mandrel in 7 to 9 rolling steps, all in line. After these rolling steps, the mandrel is removed from the pipe. The irregular ends of the pipe are saw cut. During rolling over the mandrel, the temperature has dropped to approximately 500 degrees Celsius, making it necessary to reheat the pipes before any further hot rolling can be done. Temperature and performance of the mill is closely monitored in the control room. After reheating, the pipes are again rolled to their final shape and length. After this final rolling step, the pipes are air-cooled on the cooling bed. Pipes are transported to the dispatch area and transported to a coating yard. The pipes are loaded onto the rack to enter the coating plant. The pipe ends are sealed to prevent any ingress of moisture or dirt during the next step in the operation. The pipes are washed and preheated to remove all moisture. Before they enter the shot or grit blasting machine, which will create the required cleanliness and roughness of the pipe to secure proper bonding of the coating. The pipes are internally transported to the inspection location, where all pipes are visually checked for the proper cleanliness and absence of surface irregularities that might negatively affect the coating. The ends of the pipes are covered with tape to avoid the coating bonding on the pipe surface where the coating cutbacks are planned. Since the actual pipe coating is a continuous operation, steel couplers are inserted into the pipe end to make it possible to create one unbroken string of pipes during the coating operation. Before the actual coating is applied, the pipe is preheated using induction coils. Using several coating stations positioned closely together, a 3-layer coating system is applied on the pipe. The top layer of polypropylene is wrapped around the pipe in an almost molten state. For safety reasons during pipe storage and in order to ensure enough grip during pipe lay, the outer surface of the coating is again roughened using polypropylene particles which will partly melt into the coating. The pipe is cooled using water. Now the actual coating operation is finished. The pipes are marked in order to trace them during all operational steps. Measurements of the coating thickness and the absence of leaks in the coating are performed. To prove that the coating is sound and without defects, a brush with a high voltage is tracked over the pipe surface. Any hole in the coating will make the brush spark, showing that at that location a coating defect is present, which of course will be repaired. The coating on the cutbacks is removed. The pipes are transported to the stockyard, awaiting transport to the Lorelei. Before the actual offshore installation starts, a kick-off meeting is organized on board to inform all involved in the project about specific details and safety matters. Before installation, a pre-lay survey is done to examine the seabed and the route as specified in the project specifications. If there are no obstacles found on the route, pipe lay installation can start. As the pipeline will have to cross 7 existing pipelines and cables, all Seas must accurately place concrete crossing support mattresses before the new pipeline can be installed. The mattress installation is done with a mattress installation frame, which is operated from the company's trenching support and subsea installation vessel, the Trench Setter. After installation, an as-installed survey is done to make sure that the mattresses are installed correctly and according to the project specifications. The specially manufactured mattresses were loaded on board the Trench Setter during her mobilization in Rotterdam. Offshore, new arrivals on board All Seas installation vessel the Lorelei arrive by helicopter. The survival gear is taken off and the new arrivals are welcomed with a safety induction. Depending on the pipe characteristics, a certain number of 12-meter pipe joints can be stored in the pipe hold on board the Lorelei. The first batch of pipes for the Cleaver Bank High project was already loaded during the mobilization in Rotterdam. But a regular supply of new pipes is necessary to continue pipe lay offshore. The pipes are brought to the Lorelei at sea by pipe carriers and are loaded on board by cranes. These cranes transport the pipe to the landing area on board, from which the pipe is transported to the pipe cargo hold for storage or directly into the bead store. Production starts in the bead store, where the pipe number is checked and registered and the pipe ends are beveled in order to adapt the special shape of the weld geometries to the selected welding procedures. After beveling, the pipe ends are cleaned and the welding collar is attached before the pipe ends are preheated. Preheating will result in a better welding performance. Once the heating is completed, the pipe section is ready for welding and is moved to the line-up station to meet the other pipe section. As soon as the pipe is lined up with the other pipe section, the automatic welding machine, Phoenix, is brought in position and the first welding pass, also called root weld or bead, is made. To fill up the complete weld, more welding passes are needed, and the pipe section is moved in the firing line to the next welding station. On the Cleaver Bank High project, the Phoenix dual torch welding system was used, enabling 2 welding passes in one run, instead of 1 pass, which reduced welding time. On the bridge, production on all stations is monitored closely. As soon as one station has finalized its activities, the ready signal is given, changing the color of the button on the bridge from red, in action, into green, ready. When all stations are ready, a bell rings in the firing line, the vessel pulls another 12 meters forward, and a new pipe joint will be lined up in the bead stall. During the second pass welding, the dual torch welding system is used. The entire pipe is kept in position by tensioners. These mechanical devices, provided with large tracks, are clamped around a pipeline to keep tension in the pipeline while it is being installed on the seabed. Upon completion of the weld, the end cap weld is made and the welding collar is removed. Upon completion of the weld, also called field joint, it's quality tested. The non-destructive testing method employed is automatic ultrasonic testing, where sound waves and clean water are used to determine the weld quality. After the weld has been approved, anodes are installed to prevent pipe corrosion. And the joint is moved to the field joint coating station, where the field joint receives a layer for protection. On the Cleaver Bank High pipeline, heat shrink sleeves were used, which means that a mastic sheet is wrapped around the joint and heated, causing it to shrink tight around the joint to protect it. Parallel to the production of the 20-inch main pipeline and the firing line, the 4-inch piggyback pipeline is produced. The 4-inch pipeline is pre-beveled in the vessel hold. The piggyback line is welded by hand. After grinding and non-destructive testing, a heat shrink sleeve coating is applied. Just before the pipe leaves the firing line, the 4-inch piggyback pipeline is attached to the 20-inch main line. Spoilers with fin are strapped to the pipe to enable the pipe to bury itself in the seabed. As soon as the spoilers are in place, the 20-inch main pipeline and the 4-inch piggyback pipeline leave the firing line, guided by a steel structure called the stinger. The stinger will guide the pipes in a controlled way onto the seabed in the shape of an S, As soon as the pipeline is installed, post-lay survey is done to make sure that the pipeline is installed correctly, according to project specifications and within the specified corridor. After the installation of the first set of mattresses and the pipeline, the crossing protection mattresses with artificial seaweed were installed. The specially manufactured mattresses were also loaded on board the trench setter during her mobilization for the project in Rotterdam. In order to examine the position of the pipeline and the previously installed mattresses, a pre-installation survey was first carried out before the trench setter could install these last mattresses. After installation, an as-installed survey is done to make sure that the mattresses are installed correctly according to project specifications.